Hello, so welcome to the fifth and final part of the lecture. I actually have made put this error and power in a separate video. So, what's it all about? Well, if we think about what you want to do is reject false null hypotheses and accept true ones. So, the idea of how good your test is at rejecting a false null hypothesis, i.e. finding a signal when there is one in your data, that's the power of the test, and you want your test to be powerful. If there's a signal in it, a pattern that's real, then you want to detect it. So power of a test is important. What you don't want to do is make an error, and I don't mean an error of calculation, I mean adding 2 and 2 and making 5. What I mean is an error inherent within the system. So and it's inherent in the system because we're dealing with uncertainty, as we've talked about previously. So there are two types of error. You can make a type 1 error, which is you reject a true null hypothesis. So you think you've got a statistically significant result, and it's not. Alternatively, you could accept a false null hypothesis. In other words, you miss something, and that's what you don't want to do that because you'll miss a signal in your data. That's a type 2 error. So you've got these type 1 and type 2 errors. So to be honest, I find it myself very hard to remember which is which. So I got this little means of remembering it from Ellis, a book on effect size from Ellis. So a type 1 error is like telling a bloke he's pregnant. You found something actually that isn't there. So, and the probability of doing that, you actually determine yourself. That's the critical significance level alpha. So that's in your control. The probability of making that type 1 error a false positive is set by the alpha level. So, if you accept the null hypothesis, conversely, you could be making a false negative. In other words, you could be saying there's nothing going on when there is something going on. And that's a type 2 error. It's like telling an obviously pregnant woman she's not pregnant. The probability of doing that is beta, which isn't easily defined. It's not as easy to calculate as, or you don't decide on it like alpha, so it's something separate. So we won't go into much detail there, but it's got that symbol. So these two types of error are false positive, which is type 1, which is like telling a bloke he's pregnant, and a false negative, which is type 2, which is like telling an obviously pregnant woman she's not pregnant. And those are the inherent errors within the system. So the power of the test is a measure of how good it is at rejecting a false null hypothesis. That's what you want to do. I.e., it's a measure of how good your test is at getting it right. And the probability of rejecting a false null hypothesis is 1 minus this beta. So the power of your test, beta, comes from the previous slide. Just remember that was the probability of making a type 2 error. So power increases with increased sample size, increased effect size, and decreased background variation. So increased sample size, I think you've got that. That's the more, say we do the ground squirrels, the more ground squirrels you measure, the more powerful the test is going to be when you use it. If the effect that exists is big, if for example male and female ground squirrels were hugely different in body size, that would increase the power of the test. It would be easy to detect. If lots of other causes of variation in the system, causing differences in size in males and females other than sex, if there's less of that, then your test is more powerful. So if you're controlling all your background variation, you've got a more powerful test. Typically, effect size is fixed, that's what we're measuring, and background variation you control as much as you can. So it's normally the sample size that is what we can increase easily to increase power. Okay, so what are the implications of this? So implication of a type 1 error is that you're finding something that's not, and the probability of doing this is alpha. If alpha, critical significance level, is 5%, on average you're going to make a type 1 error once in every 20 tests you do, and that's just, you just have to accept that. So think about the implications beyond that. Say you're reading a paper and it's got 20 tests in it, of which one is significant, and it makes a big deal about that one test. You need to be cautious. You need to have your critical evaluation skills on. Okay, so power of the test, what are the implications of that? How good the test is at rejecting a false hypothesis. How good it is at getting it right. The problem is, if you haven't got much power, it's not worth doing. So you might think, well, just but on the other hand, you say, right, I'll ramp up the sample size as much as I can. Well, that may not be possible, and it may not be ethical. You might, if you've got enough power, why do you need all the expense and ethical costs of doing more? So sample size is quite crucial here, and there's a whole bunch of techniques called power analysis, which you'll learn about more as you do project work. But these help you decide on a sample size that's not too big and not too small. Not too small, that means you're never going to find a difference, even if there is one. It's too weak, and not so big but big enough to make it a reasonable chance you will find without being excessive. So, error, type 1 error, and power of a test. It'd be good to be aware of the implications of these, and as you go on in your course, you'll in terms of critical evaluation, the literature, and developing your own work, research, these two things come in more. So that's the last part of the lecture. That's on statistical error and statistical power, and that's the end of the week 5 lecture, Introduction to Null Hypothesis Significance Testing.